Hello everyone, we're here to a tutorial of Patran Student Edition, and we're going to do a practice for tension fitting. First, we create a new database called tension fitting. We click right here on the icon, and we set the name for tension fitting. Then we click OK. Yes. Okay. Then we make sure that it's just based on model fault tolerance. Right here, model dimension 10. Then we see Nastran and analysis type structural. Then we click OK. And we're ready to go. Well, in the next step, we need to create the surface. Then we select geometry. Then we click on surface, create. We're going to create surface based on XYZ. Then we select a vector coordinates list. We put 1, 5, 2, 0. Then we click apply. And we can see a rectangle here. Then on the next step, we increase the point size so it will be more comfortable to see them. Then we select again geometry, we choose transform, then point, then translate. Yes. Then the translation vector here. We're going to move the point on X 0.5 units. Then we select this point. We click on point list so we can indicate the program at which point we want to translate. For the first point we're going to translate, it's going to be the top left corner. So it will be this one. Because this one auto execute, it will execute automatically, obviously. And here's the point that has been translated. We repeat these steps, but for moving the point 0.5, but now on Y direction. And this time we're gonna translate this point. Auto execute point here. Then the next step, we're going to create a curve in order to connect these points. So we go to action, create, going to create a curve, and the method will be with points. So now we choose the starting point. We'll choose this one, doesn't matter which one first. The ending point, it will be this one. And we choose apply. It was on auto execute. Yes, sorry for that. No. Then for the next step, we need to create a surface. No. We need to break the surface. Sorry for that. We're going to break this surface, so this will be separate this one from this one. So we go to geometry, fit, go on surface, and break. So we need to choose the surface list. The surface list in this case is going to be. We need to turn off auto execute because it's a little bothering. So we need to select the rectangular face for surface list, and the break curve is going to be the new curve we already made. Then we click apply. Do you wish this? Yes. Click yes. And now it separates the surface from this one and this one. Now for our next step, we're going to erase this part because we don't need it anymore. So now we go to geometry, delete, and we choose the surface option. Then we click that triangular face right here, and we can apply, and there. Now we have our surface that is needed. Then for the next step, we're going to extrude the surface and to create the solid. So for this step, we need to go to geometry. We're here. Then we go to the action of create. The object will be a solid, and the method will be extrude right here. Then we make sure is the option set on type meshable. Then the translation vector, we give them the coordinates or where the solid is going to extrude. So we're going to extrude it 2 units on the Z direction. So give me 2 units on Z direction. Then we click for apply. We need to select the surface list. Sorry, we select the only surface we have, and obvious. I will execute on. There is it. So for better looking, we go to home, and we set the smooth shaded so it look like a solid, like a real life solid. Then we select the ISO 1 view that is pretty comfortable to work with here in Patran. So the next step will be create a shell solid. Okay, for this we go to geometry, create solid method. Nope. Edit. We are going to edit the solid. We're going to do the solid method with a shell. Yes, the thickness of our shell is going to be 1/4 of a unit or 0.25. And then the solid phase we need to do the shell is going to be this one, and this one. So here, in order to select multiple faces at one time, we click on the shift button. Then on the surface we need the other face. Okay, well, we need to turn off the auto execute, sorry. Okay, again. This, shift, and shift. And we click apply. Application geometry. Why do we have an error here? Solid, edit, shell, turn off bodies, no solid face, flashing bone, this on the solid. Let me see this. Sorry about that, we had a little error we need to correct. So we make sure we turn off the auto execute, then we select the solid faces. Then we need to make the shell, shift, here, here, here. Then we click apply, and there is our shell. Then for the next step, we're going to create fillets. Fillets, we need to edit, solid, let's blend. So we choose the radius, constant radius. Selected, constant radius of 1/4 of unit. Then for the next option, we're going to choose solid edge length. Then we select the inner edges. Five edges. Then we choose auto execute. Then we click apply, and we can see our edge is filleted. Then for our next step, we're going to create a hole, a big hole here. So we make sure we see we are in geometry, create solid primitive, then we select the cylinder option. Now that we're on cylinder option, we give the height of the cylinder of 2 units. The radius will be of 0.25 and base center point. On our base center point, we give our coordinates of -1 on x, 1.25 on y, and 1 on z. Then we click apply. Correct this. Now we make sure 0.1. And here is our solid. Now we need to go to action, edit, solid, boolean. Then we make sure it's on subtract. Yes, subtract. Target solid. For the target solid, we make sure is this one. It's going to be hold. The subtracting solid list is going to be this little cylinder we just made. Then we make fly. Not Parasolid list, unable to process a request. Why? Target solid tension fitting. Yes. Here is it. I don't know what happened. Let's move on. Then we click on wireframe view. There's our hole. Now we go to geometry, transform point. We're going to translate some more points. Then we translation vector. Translation vector. Here is it. We're going to put the point on -0.5 on z direction. -0.5 on z direction. Translation point. Then we select the base of the fillet. The point that is going to be translated. It's going to be this one. So now we get a point on the middle. Then we need to translate 2 more points, but now with a minus 0.75 on the x direction. Then we click, then we select the point list, the new point we just created, and we execute it. There is it. Then we're going to make another point. Okay, we're going to make another point, but now on the double distance, it is going to be 1.5 minus 1.5. Then we repeat the count 2. Then we select our new point, and there are 2 last points created. Then we can move on to the next step, and the next step is create hole for tension fitting. We're going to create the holes for our tension fitting. Then we move to edit, solid. We create solid, create solid, primitive, we create cylinders in order to make the holes like we did on this one. So our holes are going to be -1 height and 1.125 units for the radius list. Then we choose our 3 points. So first, this coordinate axis, choose point 0.2. And for our points, this point. No. This one was on core 2, so this core 2, and our points. For this, we're going to select our newly created points with Shift. Oops. Let's stop this. Now that our solids are made, we can repeat the same steps as on the other. We move to edit, solid, boolean, extract. Our target solid is going to be the tension fitting, and our subtracting solid list are going to be the 3 cylinders we just made. So we select this one, this one, this one. Now we click apply, and our holes are made. Yes, we click on the smooth shaded and we can appreciate better. So we move on to the next step. Create cylinder to print the tension fitting. So now we choose the wireframe B option. We choose create solid primitive. Then we choose the cylinder option again. We need to create a point first. Action create. Create a point. X, Y, Z arc center. Our curve list is going to be this one. So now we have a point there. Now we're going to create a new solid on the primitive. Add the cylinder option. Now our cylinder is going to have a height of 1 unit. Our radius list is going to be 0.371 for the radius list. Then for base and point list, we're going to click on this point and make sure the coordinates are 0.1. Then we click apply. There's our new cylinder. So we need to use now switch to that option. Here's our new cylinder. And then we move on to the next geometry. Edit, solid. Then we move on to the imprint option. Then our solid list A is going to be the tension fitting. All this, and the imprint is this little cylinder. Then we click on apply. Okay, forget it. It already imprinted it. So for the next step, we're going to delete the cylinder. We're going to delete solid, and we're going to delete this cylinder. Then we click apply, and it stays the imprint right there. So we move on to the next step. Now we're going to mesh this solid. So for the meshing, we're going to create on first the meshing tab, create a mesh on the type solid. We're going to select that TET4 due to our license. We have the student edition, so it doesn't allow us to use more number of meshes. We click on the input list. Click on the input list and select solid. Here's the input list. Then we select our solid. We remove our shape from the made calculation. and we enter the value of 1/4 unit. Global length multiply, and this is our beautifully meshed part. It's not shaded, so it looks better. Here's our mesh part. So we can move on to the next step, that is create loads and constraints. Now we move to the loads tab. Then we create a load. Total load element uniform. Enter force as the new set name. Here is it. We're going to call force. For the set name, and we click on input data, and the load is going to move at minus 5,000 on x equal minus 5,000 on x, and 0 and 0 on y, and y and z. Then click OK. Then we select application region, our solid faces. Solid face created by the new printing hole. Choose this one. Then we make sure we click Add. Then we click OK and Apply. Then there is our load created. So now we're going to pass it. Now this one is going to create a displacement load that we just, the first one, we select on the nodal, then on the name we set it on, it's going to be called fix, this one. This is going to be the one to fix the tension fitting. So then we move to input data. So on translation we set it is 0, 0, 0 on all directions. Then we click OK. Then we set the application region. So for this application region, then we click on select geometry entities, and we're going to select the surface or face icon. This one is right here, it's already selected. And we're going to choose all the 3 holes we just recently made. For the geometry entities, we're going to select which I'm not sure if it is correctly chosen. Why doesn't let me just choose a circle? My thing is this. It is on points, no, it's solids. So why surface and face? Geometry. Now we need to choose the surface or face. Is this one? It's kind of confusing because it's the same icon. So we choose the cylinders. No, I don't want the cylinder. Why I can choose the cylinder? Just the cylinder. There you are. Then we click on Add, and there add our constraint of displacement. Then we click OK and Apply. There is our fixed loads. So we move on to the next step, that is create the material properties. Then we go on properties. The material is going to be an isotropic type. manual input. Then our material is going to be called aluminum. Then we click on input properties. And we're going to have elastic modulus of 10E6. 10E6 and a Poisson ratio of 0.3 units. Then we click OK and we click apply. Then we already create our aluminum material. Then we create the next step. We create the 3D element properties. Then we go to the property section. Then we go to 3D. Where is 3D? Can someone please tell me? Object 3D and teaser project. Nope. We're going to properties. Create 3D. Nope. 3D. Solid create. Yes, we're on so this option is selected. 3D solid. We're going to click on 3D text for the property setting. 3D text. Then we click on input properties. The material name is going to be aluminum issues. Then we click OK. Then we click for application region. And select member is going to be all solid. Then we click on add. Then we click OK. Then we click apply. And our material is like this. So the next step will be check the load case. Then we go to load case. Load case is the one of these icons. Locate this one. We're going to modify. We're just going to make sure that our loads are properly made, that they are there. So we click on the load case name default, and we make sure that their displacement and total load is fixed force. Here they are, and now we can click just cancel. Yes, we make sure they exist. So we run the analysis now. We go to the analysis tab right here. Then we choose the where's my menu? Oh, here is it. There is which is analyze time model for run. Open C Nastran. Translation properties right here. Translation parameters. And we choose we make sure it's on translation parameters. Yes. The web print. We are making sure that XDB and print is selected. XDB and print, where is it? Yes. Okay. Then we click OK, then solution type. There is a linear static, yes. And we're going to assume that is correct. Then we click OK, then we click apply. It's doing it. Great. So now we can move to the next step on access the results. So we go to the analysis, access results, access results, attach on the XDB file, method, pursue entities, yes, finish. And then we click on the select results file. Oh my god. We're going to what happened here. Oh, cell. We select that, we click file, then there's already attached the XDB file. We can move on to the next step on display results. Then we move to results, tab, then we choose create deformation. Deformation is select displacements transitional, and then we click apply. There we can make sure, yes, these are our displacements. Then we can move on to the next step. We can display on erase, then we erase under geometry erase. So we're left just with the deformation. Then we click on display attributes. That is attributes. Erase it. Then we remove the check and show on the form. And render style, we choose the shaded option. So we click apply, and here is our deformed piece. Look at that, beautiful. Then we move on to the next step. That with display results, create fringe. Create fringe. Then we move to stress tensor, rise the bottom option, stress tensor. Then we select display attributes. Display two element edges. Then we click apply. And here is our final piece. And that's all, my friends. Goodbye.